Hi, good afternoon, everyone. Thanks for joining. So we'll wait for another 5 minutes. So let others can join. Okay. So we'll begin the session. Hello and a warm welcome to everyone joining us today for this exciting session on integrated circuit product value chain for a futuristic India, brought to you by L&T EduTech as part of our masterclass series. This masterclass series is designed to deliver contemporary, industry relevant knowledge to students, educators, and professionals across academia and industry. Over the next hour, we will explore the complete life cycle of IC product development from concept to production. We will look into how custom ICs are designed within India's fabrication ecosystem and gain an understanding of the career opportunities in chip design, IC verification, and system integration. We will also learn how academia is adapting to meet the fast evolving needs of the semiconductor industry. So get ready to dive in, take notes, and ask your questions because we are going behind the stack. Before I introduce our speaker for today, I request all participants to drop their questions in the comment section. We will address them during the live Q&A session at the end. And don't forget, we have a special bonus waiting for you, so stay tuned until the end of the session. It's time to hear from our expert who will walk us through today's insightful session on the IC product value chain. It's my privilege to introduce today's speaker, Dr. Venkatalakshmi Ma'am, a distinguished expert in the field of electronics and communication engineering. She brings deep expertise in cutting edge technologies such as industrial IoT, artificial intelligence, edge computing, 5G, and SOC design. With a strong track record of applying these innovations to real world industrial use cases, she is also widely recognized for her ability to integrate design thinking into capstone project development. Dr. Venkatalakshmi's work is dedicated to bridging the gap between academia and industry by aligning academic outcomes with evolving industry demands. Her approach emphasizes skill based learning and job ready competencies, making her a driving force in preparing students for the future of technology. A warm welcome to you, ma'am. We are truly excited to have you with us today. Over to you, ma'am.
Thank you, Maria. Thank you. Hope my screen is visible.
Yes, ma'am, it's visible.
Yeah. Thank you, Maria. Very good afternoon, learners, and the gathered crowd of the aspirants of integrated circuit. A warm welcome you all to L&T EduTech Masterclass series. So today we are going to have a discussion on how the integrated circuit product value chain for the future India, we're all at it, and how we can take it forward is going to be the today's discussion. I have just made the components of today's discussion into 5 segments. First, I will just give you a glimpse on how the IC market is, what are the motivational factors which make us, all of us, to gather today to talk about the IC. Second aspect, the value chain of the total IC products and the internal components. I just segmented into 3 stages mainly. One is onto the design aspects, two is onto the front end manufacturing aspect, and the third aspect is the back end manufacturing. So we will just have a deep dive onto all these 5 areas in order to have a complete view on how we are in India towards the integrated circuit products. As a first point, let us consider why ICs are today we are speaking is a second question. First of all, how IC is occupying seamlessly into our life. This is a very interesting scenario indicated by the Accenture report, where our daily routine is able to have different activities. This is a sample activity highlighted, where any device you take, starting from the alarm clock, proceeding with the EV car today, which is picking up, and a lot of vending machines today, very casually, all of us are having an access, proceeding with a lot of healthcare access, what we are trying to have, and the smartphone, which is a very typical example of the IC's domination. And this complete daily routine indicates how demand is and integrated chips are today. We are in the era of a third era of computing, where we are just monitored by multiple computing devices. Inside this particular room where I'm interacting with you, I'm just facilitated by when I just enter this room, only these lights were switched on. Means there is some computing device which is having the power optimization where it is able to monitor my presence and then to switch on the light. Similarly, I hold a wristwatch, which is a kind of a smartwatch which supports my health system. I'm interacting with you through PC, which is a laptop of mine, and I do have a mobile, which means today every one of our individual tasks are supported by multiple computing devices, where we are very clear that we are living in an environment or an era of third era of computing. So all our components are by default, starting from this mouse to all the devices which I spoke with you, are all having an IC, particularly the mobile, which is today a default asset with all of us. Like our wearable kind of a thing, we are just carrying this particular mobile, which indicates almost nearly 169 semiconductors inside this smartphone, right? So knowingly some of the, as a user, I may be knowing something. As an engineer, I may know little more inner, but as a designer, if you just go, it has a wider list. And today, every one of us carry this mobile phone, which makes the volume of productions need in the market, and how optimistically we have to use it is the next question. So the IC is having a seamless integration inside our life. Having that understood, as a big picture, when I take it up, there are major kind of sectors where we may be connected as an employee, or you may be a kind of an entrepreneur onto these kind of sectors, or you are an employer, employee, or small workers, whatever it is. These sectors, when I just take it again, every sector is in need of wide range of integrated circuits, starting with the consumer electronics, as I highlighted, the smartphone, the PCs, the augmented reality, and the extended reality applications which are coming up. In augmented reality, I may just fuse the digitization onto the objects. In the extended reality, I may have a complete simulation of the environment. Smart homes are becoming nowadays very common. Smart cities are one of our major projects in L&T, what we are carrying out. So, day by day, the usage of integrated circuit by this sector is solid in consumer electronics. Coming to the industrial electronics, I will also elaborate some of our examples where how in our industry projects, the immense usage of ICs are involved. So, smart manufacturing or an energy sector, wherever it is, we are by default in need of ICs, telecom and networking, automotive, which is now coming with the V2X, vehicle to anything communication, because an autonomous vehicle, we would like to have a connectivity in a pervasive way, which means the V2X connectivity, right? So the automotive sector, data centers, right? Data centers are in demand of huge GPUs for the cloud storage. Again, cloud is another technology which is seamlessly integrated with our daily life. Like when I say equivalently, the daily life routine, we just book vehicle, we book online certain things, we just purchase everything online. Today we are into a very big transition of the cloud usage. So the cloud usage demands the data centers in a different models of data centers. That's coming up as a big sector, right? The kind of memory, which is a high bandwidth memory requirements, the SSD devices, the non-controlled SSD devices, everything requires a kind of IC at the behind. So indicating the demand of the bigger picture of the growth drivers behind ICs. Now, when I just move on, we know all of us. So the reason we all have assembled here is we know the faster requirement of IC's rate, which is indicated by one of this survey. Like this, we may come across today, every day there is a special news on semiconductors. Realizing this growth, every industry is trying to have an indigenous model of IC production. So where are we as Indians? And what is our market boom expected is going to be our discussion. So all this brief I just brought to you just for a warm start of information. So the common inference out of this entire slide is the demand for integrated circuit is an increasing phenomenon. And so the IC market is going to be pervasive, be it you're a manufacturer or an employee or in any other form of stakeholders. Are you doing some software for that IC? You have a market. Are you just a retailer buying the ICs and just making your business? You have a market. It's not something like whether I'm just now learning a BTech course and I'm in the first year. After 4 years, what could be the transition? There's no such question. ICs have been occupied in every device. And so there's going to be an increasing phenomena in this market. And we are having this as a kind of a sustained kind of a demand. Having this as an inference, I would like to take you on to the value chain model here. There may be multiple value chain models we may come across in different literatures. The key components I have highlighted in a simple framework so that we all can understand what's the exact value chain of this integrated circuits. The major components or the soul of this value chain is the three stages of the work, like the design of ICs, the front end manufacturing of the ICs, and the back end manufacturing. These three are the soul of the element of the value chain. But it's a bigger network. It's a very big process in the sense the design, even though I have made as one single block, has got a lot of interim stages of design and which is also supported by the pre-competitive research and development happening around in the nation. We will see more details on each component and the core intellectual properties, which are reusable designs by the companies, and particularly the tool which is used for the design. So the segment of design is supported by the subsegments like how much core IP a nation is able to own, how much the pre-competitive research and development is happening in the nation, who are all the players, are we at competent, and how fast we are too. All that makes the design to be a successful solution in the market. Similarly, the EDA tools. In the same way, when I just move for the front end manufacturing and back end manufacturing, they are also substantiated by another bigger segments of the industries. There are raw material suppliers in the nation, those who can give the raw wafers, the materials for the actual insulating material or any other kind of the adhesive materials and chemicals and packaging materials for the back-end manufacturing. Similarly, the semiconductor manufacturing equipment suppliers. So that's a big business. It's a very bigger network, and that's the reason it was always in the global market as a value chain. Now, from global to nationalization, it is coming up. We are in that transition. So we are having the discussion focusing upon what's happening in this transition, what are the doors open for this kind of a transition, how far it is acceptable by us, how far it is beneficial by us, all are going to be the discussions. I just feel all of you are in alignment with our discussion. The value chain of ICs has got certain core areas like this: the design, front end, and then back end manufacturing. All of them are supported by the other segments too, right? And finally, the distribution happens. So now let us have the insight of all this, how they are at the global market and how they are at the Indian context, right? Before that, if you look at, as briefed earlier, for each of this particular segment, there are different players in the current existing scenario. And all of them are giants, of course. Some of them we may not be aware of, but silently they have been working on to the integrated circuits in a massive scale. Then why we are today talking about it in an exclusive manner? If we ask ourselves, the demand for multiple computing devices and the kind of digitalization happening around us keeps demanding more and more products, where in the global market the lead time is becoming delayed, material shortage, a lot of demand makes the cost of these solutions also to keep increasing. So every nation, developing nations, are thinking about how to have that cost to get cut and then to make indigenous solutions. So in that context, if you look at some of the sample players onto the IP market, ARM is the master player. Onto EDA, Cadence, Synopsys, Mentor Graphics. All the three are owned by US only. All the three are the only solutions available for the design. And fabulous design. If you take, there are competitive companies like Qualcomm, Nvidia, Xilinx, everybody is there, but still they make use of an integration of the EDA tools. And sometimes they also go with the fabulous design along with an IP based model. Then there are some companies trying to work as, okay, I will plug everything and try to make a product. That's how the integrated device manufacturers are, those who can take and hold the responsibility of the integration and then to supply for the solutions. And in one space, they are the unique players, and in another side, they are just doing integration of the devices. That way, we have TI, Samsung, Intel, all are available. So coming to the equipment market, here you must have heard about Applied Materials and KLA as the two major players. Hitachi is also there. Lam is coming up. And the next area is foundries, which is almost uniquely occupied by China and Taiwan, where TSMC is the major player over there. And then we do have assembly, testing, and package kind of operations. Similarly, the raw material suppliers. So these are all the typical players as of now in the market doing the job onto one segment of operation of the total value chain of the integrated circuit. So very clearly, this indicates that this is actually a global market. And now moving on with the insights of our IC value chain. As I have highlighted in this architecture, I would like to go with the typical segments where we are trying to have how the Indian market is. That's how we wanted to have an analysis. So when we look at the pre-competitive research and development, we are only the beginners. So we are just establishing through various schemes of government with some R&D at institution levels, that too with IITs and IIMs we just started with. But government is making a lot of schemes like the DLI scheme, that C2S scheme, and we are trying to bring out some products, and we have some product history. Recently, the one of the NIT also has brought one complete IC and given for the fabrication. So we are almost near 30 to 38 owned chips, that too for 180 nanometer kind of a size. So we are beginners. We are very, very beginners, we can say, onto the pre-competitive research and development initiatives. Whereas when you look at the global market, right, for almost edge semiconductors of 10 nanometer size, there's no competency for the actual company which uses extreme ultraviolet photography, photolithography technology. This has been established in 1990s itself. So there's no competitor in the global market itself for this. We are still with 180 nanometer things to get started with, but there's no more competitors with them beyond 10 nanometer. So this way, the research and development has got established as a pre-competitive research and development in US, but in global level also, in Japan also, there are some kind of such a pre-competitive R&D. I'm just highlighting one of the example with the US. Whereas, but if you look at, there are multiple countries with the different R&D initiatives, particularly the countries those who are already in the game. India is entering into the game. So now coming to the second aspect, integrated circuit design. If you take this particular segment of the value chain, it is a highly skill intensive. So that's a area where with our population, we are very confident we will be able to play a better game too. This requires actually a collaborative support. So when we say the design is again having a lot of inner segments, like starting with the design, the verification, the physical design. So it has got again multiple segments. So it requires a collaborative effort. There in the global market itself, people of integrated device manufacturing also are there, like Intel, fabulous designers like Qualcomm. Platforms are coming up in the market, platform designers, so that through the cloud, the EDA tools are shared. Through the cloud, verification is encouraged, like Apple and Amazon are already into such market. And some end user investor, like I need this much, this pattern of an IC for this much volume. If the end user is there, then the production or the manufacturing is connected. So like that, the end user investor, all this amalgamation is required in order to have the design to be a kind of a successful solution. So in the global market already, this is how the design is happening. But of course, all of them are the players with origin of different other countries. But when you come to Indian context, we just have IDM with Tata Electronics. Okay, they are into the integrated design manufacturing setup. So Tata Electronics again in combo with the semiconductors lab at Chandigarh, which is the government owned fabrication lab meant exclusively for our defense. Of course, there again 180 nanometer. They are the one set, right? IDM people. So the IDM people of Tata Electronics, which is not again widespread, with 180 nanometer, there are some initiatives along with SCL. We are in a very small scale kind of a support onto the design. Then if you come for fabulous design, we also have entered into the market. Larsen and Tubro, we have opened up our floor recently, and we are almost 2 years old, little less than 2 years, L&T Semiconductor Technology. And we have just stepped in onto the fabulous design as an initial. Later, we may just evolve out as an IDM. Tata has started with the fabrication, and then they have already started with some of the design initiatives. So they have little ahead of us in IDM. All again in an initial stage. If you compare us along with Qualcomm or Intel, their contributions are quite many years, and they are already serving for the global market, which makes us to feel that we are very, very beginners. Now, in core semiconductor, Mind Grove, all of us are into fabulous designing. And platform support recently, HCL and Sankalp has started addressing the needs in the nationalized requirements. But if you look at the volume of our business or volume of our contributions onto all these areas, it's only limited, unlike the global market or the global market. Intel's comparison in along with the Tata Electronics, if you make a comparison, it will be like 1/100th of our effort. That's how we are into the integrated circuit design, which is skill intensive, which is a very promising area we anticipate, right? So the whole entire crowd assembled today, my submission is to think of the kind of the design area where what is possible, where is our strength. If you are an academician, think of how to enhance this area. If you are a student, think of how to learn more onto this design area. This is how today's scenario is. Then moving on for the wafer fabrication, right? Which is a component under the front end manufacturing. This kind of a segment is normally capital intensive. So, where the giants are only TSMC and Samsung. Even to begin with, many of the other countries like India, whomsoever is trying to indigenous their total value chain, are taking initially the support from TSMC and Samsung and trying to do the kind of the establishment. Probably down the line, they may be able to have their own self-established centers for the wafer fabrication. Right now, TSMC and Samsung, and we have 180 nanometer SCL, as I have highlighted. Since it's established by the government exclusively for the defense operations, it is not end to end, it is not for all the products. It has got a protocol not for supporting the commercial products, it's only for the defense products, right? So we are not having the end-to-end facility as far as the wafer fabrication is concerned. And coming to the APT, that is the assembly, packaging, and testing. So there again, if you just look at, it is a less concentrated segment, and where again China, US, and South Korea has got the major players. We again have contributions. See, the entire list, if you look at Indian context, we are there, but in a very, very micro level. So the micron technology, which is the available one unit in Gujarat near Sanan, is one of the unit trying to support for APT. But in the global market itself, as APT is a less concentrated segment. And moving further, the EDA and the core IPs, which makes the reusable design, which is again a segment of design, I can say. And again, I have already highlighted there are only 3 EDA tools, which are from CAD and Synopsys and Mentor, all are from US. And ARM is into with some of the IPs. They are just into the IPs. EDA players are only supporting for the IPs too. Whereas in the Indian context, we are also trying to have some of the IPs. InCore is also into some of the IPs. But if you take whether are we into EDA tool development, yes, we are. We again got initiated with CDAC, IITs. Some of the EDA research has got initiated. Coming to the SME, that is the machines required for it, then if you look at it is again R&D intensive. Okay, again a huge capital is required. There, if you take applied materials area is one particular major player, and KLA, again it's in US. Netherlands has got a minimal contribution. Whereas if you take Indian context, Sahasra group of Rajasthan has got to some extent this kind of machineries. Then coming to materials and chemicals, if you take the entire process of the operations, it is almost 300 different types of materials and chemicals are required, which is a complex process, we can say. Japan is in front, US, and then little in Europe. Whereas Indian context, Tata Chemicals is doing again for a limited supply. And then Navin Fluorine International, there is another concern. These two players are there for the chemicals. So, dear team, those who have assembled, if you look at this entire 7 segments of the IC value chain, we are at the beginner's level. Now you can correlate like what are the opportunities around us, what are the scope for us to move ahead, right? Before we step into this kind of initiatives, which almost like 2021 Indian Semiconductor Mission was initiated by 21 or 22 was initiated by the Indian government. Before that, in 2000s, if you look at, we were in need of the ICs for many of our products which are assembled in Indian soil, where TVs, washing machines, PC, telecom, banking, industrial control, power, whatever is our application, we were depending upon the different ICs to be obtained from the different various players in the global market. It is not like I have the IC internally available. It's from different teams. Of course, it was a smooth business, we can say, but what is the pain behind it? When you just have a look into it, I can say that during the COVID incident, one of the car manufacturing company, which is able to have almost $20K of that particular car, was just hung up in operation because of a $2 chip lacuna. This was the incident happened when I depend on, like in the previous slide, for all my products, ICs to be imported. And when you just look at the global production model, that makes my friend of the end customer at a high price point. Once if I just do all the operations in the global market, and when the product comes into my desk for my actual end product like washing machine or whatever it is, the IC cost gets huge increase, right? Then software, hardware, equipment, and manufacturing diversity, right? It is not from one vendor I'm able to get one IC, even though I highlighted here Motorola supplies me. If you look at the value chain, there may be an IDM where the IDM depends on again the rest of the input, which makes our complexity in handling the particular equipment, right? If I would like to have a failure in software, I need to connect with two, three parties, whereas if it's a hardware, I should have a diversified path. That makes our servicing complexity, and ultimately mostly the ICs are thrown out rather than having a kind of a repair kind of a work mostly. So it is like we are not having a comfortable or a conducive operation. Even while doing assembly, if I face any problem with IC, I'm unable to have the fixation of our errors. This is how the actual scenario is in 2000s of India. So that made us to go for a kind of a planning in the global market rather than having entire thing in the global market. We would like to move ahead with our in-country integration. I want to just stress upon here what are the benefits I can just get if my total value chain becomes an in-country integration. The first beneficiary I would like to say is industries like us, Lazan and Tubro. To emphasize this, I would like to go with one small information of ours. It's not getting. Yeah. If you take our operation, we are into mobile cloud computing operations. You know, like Lazan and Tubro is a civil construction company, and all our vehicles involved in the construction in different remote sites, we will be monitoring through cloud. And these are all mobile resources for us, mobile assets, I can say. Each of the asset, we will be having an ID, and they will be attached with a kind of a gateway device, which is IoT connected. And we capture the health of or the status of this particular vehicle. This is actually a concrete mixer. These vehicles status, whether the fuel is there, whether the engine condition is okay, whether the drum is rotating, all the conditions, we just monitor it with the help of a cloud, and we are just doing it in the dashboard, the health analysis, and any downtime of this particular vehicle will lead a loss for us. So to avoid that, we closely monitor it, take any kind of a proactive measures. If at all the fuel goes down, we'll immediately look for a replacement. If there is any kind of a setback in the operation, we'll try to replace it with a standby vehicle so that we see to that the downtime does not happen in our projects. This is one example. Now, these vehicles as of now are using a 3G SIM, and we are operating it with a gateway which uses a OMIC. Similar way, when you look at, we are trying to expand our business with a 5G support, where from remote itself, I can even control rather than making an operator to sit in the vehicle. We are trying to have, this is one wheel loader kind of a instrument, which we are just trying to have an remote operation itself. When we are planning for all this, we are buying a board of a gateway, we are buying RAN boards for the 5G connectivity. All these boards are having multiple features. But for my operation, I may not use all the multiple features. I may use 20 to 30% of the features. What our uh, experts in the operation feel is, since the cost of these devices are more, but it has some n number of features, If you could restrict the design for 20 to 30% of the features, it's sufficient for my operation. The cost may go down so that we can implement it for all our assets. For which, when we go back to the vendors for such ICs, there's a kind of a delay in getting as per our customized requirements. So industries are in need of customized setup in order to have an effective business for the digitalization of our assets. We are doing a digitalization of our assets where this digital transformation, we are looking for optimal edge devices which are customized. In the sense, it's not a very global customization, or we are not making any kind of a optimization kind of a things. It's very simple. Instead of 10 features, I want that IC to support 3 features. That's sufficient. But to make that design, I don't have a in-house designer, or I don't have any in-house IC manufacturing team, fabrication team, back-end manufacturing. I don't have facilities. I have to depend on the global market, which is not a viable solution for us, which remains as an extended cost. So we are not able to digitalize all our assets. We did a POC and we just make only huge cost projects alone with kind of a digitalization. This is one of the problem like industries as are facing with. And you can substantiate it by having one more reference article which I could come across today. You can just look at into this. India's semiconductor mission is paving a way for the digital sovereignty. So the experts feel that semiconductor mission alone will help them to make complete digitalization for them. That is a visualization the total experts are. The same point only I'm also trying to explain you. Industries are in demand of the in-house availability of the products of ICs, which makes us to have an power optimization, size optimization, operational kind of a comfort. For many things, we look for immediately some of our requirements, right? So this is one of the industry need, whether it is an industry of service nature or a manufacturing nature or a consultancy nature, we are looking for some kind of this in-house solutions so that we will be able to have a customized solution, whereas we need less lead time for such products. Power optimization may be possible and we may get it at a less cost too, which makes many of our projects to be a viable solution. So one of the beneficiary is industry. If I get in-country integration of integrated circuits, which we are looking for. Second aspect, R&D experts. They will be able to have a very wider scope. Today, many of the students are having an interest to just get into the research and development, where there is a common question. China is in the IC market almost for more than 50 years. How can we just make a competency for them? Might be a small question in many of the generic minds view, but I would like to substantiate an answer. China must have gotten 50 years back what kind of technology, the establishment of their machineries for the kind of any of their solutions onto the value chain of IC must have got some old setup. And they must have also kept revising it to compete with today's. That's not a point. But we are today living in a world of AI, and we are today with lot of parallel technology growth, which makes us to have a kind of a speed pace up to establish our IC ecosystem. That's the kind of message I would like to share with you. So the R&D experts can get excited having the advanced technologies like AI, and you can work upon the EDA cost optimization. Our own indigenous EDA tools can be brought in, and in all domains of IC, you can just enter and explore. That is a benefit R&D experts can take up. Any of the next third category, I would like to say that any IC manufacturing team, whether it is in the design area or in the kind of assembly area or back end, whatever it is, we will be able to have a closed loop operations. If every segment in India is addressed within India, we'll be able to have a closed operation and we can produce quality products, and the business estimations can be well drafted off, and we will be able to have an export option also for the needy countries. So that makes you to have a scope if you are a player in the IC segment. The fresh graduates, I need not say, we have a lot of placement revenues. And as a whole, the nation, one of the major aspects the nation bothered about is importing the ICs. There are a lot of vulnerabilities, and security assurance is guaranteed if I do in-country integration. So the one kind of a tagline we can come out of it as a benefit of in-country integration is we'll be able to make a sustainable nation of our country, India, right? So these are all the points I just would like to share onto the value system, sorry, the value chain of IC. So before moving on to the next, I would like you people just to have a login to Vivox. Can you all just go to Vivox? So when you just go to Vivox, it may be asking you a code. Let me try to give you a code of the session. So the session code is 125496000. Can you get your response, dear audience? Are you all comfortable to just get it? Yeah, the code is 125496000. Sorry, I am not getting anybody's response. Dear audience, Maria, are you able to check with any chat box info?
Yes, ma'am. I'm just checking.
Are they comfortable in typing the code, or can you type the code in the chat box? 125. Yeah, now I think I'm able to get some response. Dear audience, feel free to just share your opinion. So I just made a small query like, what's your feel onto the in-country integration of the IC value chain process in India? Okay, thanks for your poll. And one more small query, I just to make it in the same way the other code is there. In the same code, I think you're able to see the second aspect, which is called as my concern in the India's IC domestications is what is a challenge you feel? Some of you feel security perspective. Some of you feel capital investment. 40% of you have voted on the talent generation. Great. Academic empowerment is again another answer. Feel free to share your opinion. I think only 7 of you have polled. Are you sharing? Fine. These are all some few opinions. I just wanted to have kind of a small reflection from your end on your listening. Yeah, fine. Thanks for participating. Some of you have participated, and if you're able to poll, continue your poll. Fine. So moving on to the next segment of my presentation. Just a minute. So having this reflection understood through Vivokes, I just would like you to take it for the next segment. We have seen the actual system of value chain in integrated circuits in the Indian context. Now, what are the strategies we feel that we can step into, particularly onto the pain point of the talent crunch? There are multiple challenges for us, but still as a nation we are just driving. You must be able to see every day there is some notification related to semiconductors. I just was little surprised to reach out some of the government officials in a very free manner if it is related to semiconductor. That's how the total nation is getting tuned towards establishing something onto semiconductors. So the talent crunch, when I'm just thinking of, I think there is a curriculum update required. There are resources to be established in the venues of the campus of engineering as well as the other degrees like a chemical or chemistry students, whomsoever it is. The resources need to be established in our country in order to make our domestified kind of solutions on the IC production. Similarly, on to the learner side, as well as on to the community of the teaching side, the product based teaching and product based learning has to be triggered. One of the way to have the lead time to be less for your design is to keep the product based kind of a learning, because many of the designs, after having the product in our hands, we are unable to use for the project the challenges or the hidden views of the product. So, as an industry expert, we would like to have one point in submission to the team gathered today here. Anything onto IC, please try to have a viewpoint based on the product and product solution. And industry collaboration is mandate. Within our country, whomsoever is the player, let us not play a silo game. We have to make industry collaboration. And academia industry collaboration is also highly essential in order to speed up our involvement in the IC products to be indigenously brought in India, so that we can just first excel and satisfy our needs and then to think of the export products, right? So industry collaboration is another strategy I just would like to keep in mind and then bring it to your purview, as well as the policies on the product life cycle. That is very much essential. When all this are getting set, we may be able to have a good shape of our talents where our capability of human resource in India can well be aligned towards the need of the actual IC value chain, right? So these are the strategies I would like to just bring it to your notice. And to have a little more insight focus onto, as I have already shared, onto the total value chain, the design, front end manufacturing and back end manufacturing are the core areas to be targeted at, where the others are the subsegments supporting all these three. When I just look at an analysis of a strategy for these three, that is design, front end and then back end. So I have categorized my IC design strategies as a glance onto the design aspect first, front end next, back end followed by that. On to the design segment, as we already discussed, there are multiple segments. How the academic reform can be on one line suggestion we are just discussing over here, and how can the learning community make a focus can be in another suggestion. So design segment demands foundational knowledge. I found almost all the curriculums in the campuses are having this kind of a foundational knowledge. But the academic reform we expect is just blend the courses of the foundational informations of IC as a tool-based practices, so that the learning by the learners also should be a practice-based learning for the concepts of the fundamentals, which make us to have a strong step towards our establishment of the whole value chain. The VLSI design related courses are already there in place in the curriculum, but a lot of them are component level or kind of a sub-block level rather than as a system level approach. So the universities, those who are able to have a leverage or having a kind of a support, can think of system level approach, could be one of the reforms of suggestion onto the academia. Whereas with that, the learners also should be able to apply reverse engineering skills. We are not having any product as a kind of a very concepts with AI may arrive at little new things for us. But always reverse engineering based learning of your learning onto the VLSI design will help you to have a strong design thinking mind. So have a mind of reverse engineering skill. The front end design tools and languages. Let us not confuse with this front end followed by the next slide front end. This is onto the design as a front end, where the front end design tools and languages is another segment where today many of the colleges and universities are able to come forward, particularly promoted by the government through the C2S program. They are having the tools and they are trying to support with the front end design. But again, here, please have a journey of a product model based design deliveries, which may enhance our manpower of talent to be groomed towards the requirement, right? And the learning community, if you are one of the audience, just try to do everything as a do and learn concept as far as this segment of design is concerned. Similarly, onto verification and validation, industry validated capstone works may help for the curriculum to just get enriched towards a kind of a product. And learners can have an application based analysis skill set in order to work on such projects. Similarly, the backend, again, an industry validated capstone work may help us. Emerging specialized topics, when you look at this, is the place where we just strongly emphasize the collaboration between the academia and industry, where industry aligned courses, whether it's in the form of an elective or a value added course or an audit course, try to bring it in your academic forum so that the student can get the benefit of the exact problems available in the industry. This will help them to think of the design of ICs onto the relevant requirements with the current technology, right? So that's how we are in demand. Say, for example, designing an SOC for an IoT, designing an SOC for the 5G. What is a requirement in the industry? I just showed our own problems where we are trying to establish the 5G connected setup for our digitalization, where exactly what kind of requirements of that IC, if you are able to just try to guide it, then it will be a very, very valuable content for the learners to pick up and meet out the products in alignment with the industry requirement. And the learning community can take it up the series of hackathons, which a lot of forums today in India people are organizing. Try to take up such hackathons as a serious exercise. Try to promote yourself, your skill, knowledge onto that. That will help you to have a kind of coverage of all these design skills. And one point I would like to emphasize for the learning community is, while you're playing with any of the IC related, whether knowledge aspect or a kind of a skill aspect, have the basement, or I won't be able to segment back the embedded system from the IC design. So kindly look at with some embedded system expertise in a parallel manner. The kind of embedded system and IC is like a blended requirement. One is the prerequisite of the other, I can say. So play with a lot of embedded system solutions and try to connect those things with your design skill of IC. That will give you a very quick acquisition of the both knowledge as well as the skill. This is one tip I would like to just give it for the learning community. Moving on to the front end manufacturing and back end manufacturing. I may not be the correct expert, so I'm just telling some suggestions out of our expertise. So in the front end manufacturing, again, there are segments like fundamentals, advanced, lab, and standards, where in the academic reforms, try to fuse more relevant content of semiconductor physics related to the integrated circuits by having a kind of careful elimination of little exhaustive topics and focusing on to the semiconductor physics could be one of the reform. And on the advanced topics, please bring a lot of material science contents. And related to lab, try to establish a microfabrication lab which may be helpful for them to just equip with front end manufacturing talent to be generated. As far as the standards are concerned, the industries are looking for the fabrication protocols to be very, very strictly applied, along with the environment, health, safety kind of measures or very key metrics to be infused as a standard. As far as this learning community is concerned, you can have both physics and chemistry roles to be applied in an integrated model onto an IC product, and then usage of the tools should be your focus. A lot of mini project exercises and field works as internships may help us to just go with front end manufacturing to be focused. Back end again, I would like to have again, I'm not the concern expert where it's mostly aligned with mechanical and chemical engineering. It has its own segments like packaging, assembling, testing, and integration. So here, even though you are as a mechanical or a chemical engineer, if you would like to equip with back-end manufacturing skill set, do a lot of interdisciplinary works and take up a lot of internships. See to that all are interdisciplinary. That will help us because back-end manufacturing comes after the design and the front end, but there will be a lot of different other players. So make your efforts as interdisciplinary work. So I just highlighted in the total value chain how we can strengthen ourselves as a strategy onto the design, front end, and back end, both for the academic forum as well as onto the learning community. Moving ahead, I would like to emphasize talent requirements is just getting exploded because chips are the backbone for every emerging technologies I can highlight. It's for the smart defense, smart city. Smart defense is a very obvious, even I was just trying to make this slide little long back, but after the war recently, what all of us have observed, there's no need to talk about it. How smart all the countries' drones are getting developed is an evident example for how refined and how kind of chips are having the effectiveness in order to bring such products. So smart cities, smart homes, smart manufacturing, agriculture, take any field, guys. It is with the backbone of the chip requirement. And having said all this, I would like to have some small stories of our career path in or our professional growth in the market. We are conglomerate with 80 plus years of engineering exclusive project experience. Blending that onto the sizing market investment, naturally we are aspiring to become a little more big in a very short span of time. So L&T semiconductor history, I just would like to have a just glimpse onto you. Probably I'll just stop because audio I would like to enable, stop and then again share it again. Just playing the video. If there is any issue in the video, kindly just tell me. Maria, you can confirm whether audio is heard at your end.
Yes, ma'am.
Yes, ma'am.
So we decided that.
Heard? Audio is heard?
Yes, ma'am, it's audible.
Okay, thanks. So I'm just playing from the beginning.
So we decided that we will be at the industrial application end, we'll be at the automotive end. So 40 nanometers and thereabouts sized chips on analog basis is what we will design. So we are now putting together a team which will have maybe a design studio in US because much of this is done in Europe and US and Japan. And then the back-end detailed designing of the chip can be done with the Indian engineers, design engineers. So we'll have a design lab in India, maybe one, maybe two, depending on how we progress on this. And we'll have our marketing outpost in all major automobile and industrial equipment manufacturers, which means Japan, which means Europe, which means US. So it'll be a global model delivered from India, but conceived in the global markets. Whether this product, if it succeeds, can be made available to India, of course it can be made available to India, because India today, the time lost between producing and releasing a version or a model of a new automobile has completely crashed. Today, if it is within maybe a week, 10 days, a new model of automobile is launched in India, where whatever is launched globally. So given that crashing timeline, I think India will also be an interesting market going forward. So we think that we might require to invest up to $100 million over a 3-year period in putting together the design lab, the R&D centers, as well as the initial business development.
So I think this is an evident video, like what is our contribution and our expertise. And this was an announcement by our CFO by November 2023. And we have already started with our process. You can just find the progress of our LTSET, that is L&T Semiconductors. We have established already the design lab, almost 2 sets of graduate engineering trainees we have recruited. And we also got the tie-up with the semiconductor lab of ISRO, that is in Chandigarh. And we already got the tie-up in such a way, whatever is our design, it will be fabricated by SEL, and we are able to have an access through the cloud with the EDA tools from CDAC, and we have already made an agreement. And CP Plus is one of the customer which we have already initiated, and they are with us for making or bringing out an AI-based CCTV chip. And that's our progress with one of our client is a CP Plus. And we have signed with IBM for the edge processing. With IBM, it is a wider contract where we are able to continuously going to travel with their multiple segments with AI infusions. And recent news of ours is we have already acquired the power modules business. Even though Shankar Raman has highlighted some of the segments, we are just making it a little more wider today. And with power modules business of Fujitsu of Japan, we just made an acquisition around with what around 118 crores. So this is how we are growing, and which assures that India is not very much delayed, right? We are at it, and that's how we are. So with this note, I just would like to have a conclusion of thank you, and I'm just open for queries, if any. Yeah.
Thank you, ma'am, for an engaging and insightful session that gave us fascinating peek into the technology behind modern IC products and their role of enabling high performance electronic systems. We now open the floor to questions. If you haven't already, please drop your queries in the comments. So let's take few live questions for Dr. Venkatalakshmi, ma'am. Ma'am, so far we have received 2 questions from our participants. So I would like to request you to address the queries. First question is, can you explain about the quantum computing and quantum technology and which is best to learn in future?
Quantum computing and quantum technology.
Yes.
Okay. Okay. So the quantum technology is a bigger umbrella under which quantum computing comes in. Suppose if I don't know the audience, whether you are a student or a PhD scholar or whomsoever it is, if you have already a kind of a earlier practice on more onto the computing domain, understanding about the computational architectures, the instructional design architectures, all that, if you are already comfortable, having a surface level knowledge of quantum technology, jumping into quantum computing might be a wise decision. If you are very new and you don't have any earlier experience on processors or computing devices, then probably you can start with the journey from the beginning of the technology of quantum, and you can choose a segment of your interest. I hope I have cleared their need, probably. Yeah.
Thank you, ma'am. And next question is, what is VEVOM? VEVOM.
Sorry, I'm not exactly clear on to it.
So he has
Probably.
not mentioned specifically. Might be he mentioned what is VEVOX.
Okay. What is VVOX, sir?
He mentioned VEVOM, VEVOM.
Okay. Sorry, I'm not into. Is it any relevant domain? Anything connected with that terminology? Or is it onto a design question or a front-end question? If that is there, probably we can just look into it.
Yes, he has not mentioned clearly.
Okay. We can refer
next,
and revert. Yeah.
yeah. Okay. So, I would like to ask a few questions on behalf of our participants and industry professional, ma'am. So, let's begin with a couple of technical queries. So, first question is how do tools like EDA, which means electronic design automation, impact IC design efficiency and accuracy?
So the actual design flow chain of the EDA tools is a little matured, but the reachability of it amidst the R&D groups onto the learners is limited. The accuracy aspects, yes, there are, it is able to support, but the awareness of the entire modules of the EDA chain is not very much conducive for people those who are into design. So there are segments of RTL expertise separately, the logic design and physical design, these segments, and the flow is not very much comfortable, except few companies, those have taken for their product the connected version of this EDA tool, they are able to have a better success. But as a learner, if somebody wants to gather the complete framework learning of an EDA and to equip their design, it is not that user friendly. Accuracy and efficiency wise, yes, all the three tools are equally competent and they are able to satisfy for the product the need.
Thanks, ma'am. And next questions related to career pathway. So, how do you judge about the scope and the growth of career in chip design in comparison with careers in software engineering?
Okay. Software engineering, even though we call for the employability purpose as a different journey, we feel today's every segment is fused with the software, be it a design segment or a development segment or a testing segment. The software is a blended item. And coming to IC kind of a segment, it is having a major role of softwares. And EDA tools are also meant with the specific HTL languages and all that. But user friendliness with OOPS model is picking up. So I can say even the software engineers roles will have a different options to serve for the actual semiconductor industry. That's how the actual merges. And I would like to say this is a core engineering segment. The software engineers have to always get aligned with the solutions onto any of the engineering segment. In that way, semiconductor segment or an IC segment will have a close relationship with a lot of options for software engineers to explore and contribute. Today, Python based cloud solutions for the verification is picking up. A lot of entrepreneurs or startups are coming up with the Python based verification tools as their framework. So new product models are coming out with a blend of these two engineering. I hope I
Understood.
have given enough information,
Yes,
Maria.
yes.
Yeah,
Yeah. Thanks for your answer, ma'am. So, thank you for an engaging and insightful session that gave
thank you.
us a fascinating peek into the IC products that value performance, precision, innovation in real world applications. Thank you, everyone who participated so actively in today's session. So, we would love to hear your feedback and thoughts. So, I request all our participants to submit your feedback via the link shared in the chat now. So, this will help us to share today's webinar bonus kit in the form of sample Verila code for your practice. So, please fill in the feedback form right away. Thank you. So, before we close, a quick look into what's next. So, just a minute, I'll share my screen. Okay. Hope my screen is visible at your end.
Yes, Maria.
Yeah, thanks, ma'am. So, we offer you a series of integrated circuit masterclass with session 5 and 6 on 30th and 20th August of this month. So, where we will explore the application of AI in IC design and verification, which is by our expert Mrs. Rupali. And in 20th, we'll be exploring the revolutionizing physical design optimization with AI. So this will led by our expert Mr. Satya Vignesh. So if you know someone in the AI or ECE or EEE domain, we would benefit who would benefit from this topic. Please pass on the information to them, so you can watch out for our emails or WhatsApp messages and forward it to them as well. So once if they are registered, and we will send them a link to the master class. So once again, thank you for being part of this master class. We will look forward to you seeing again soon. Take care and have a great evening. Thank you all. Thank you, ma'am.
Thank you.